Assalamualaikum and welcome back to my lecture. Today we're going to continue to the next part, which is principle of moment. According to Varric theorem, it states moment of force about a point is equal to the sum of the moment of the force. As you can see in this figure, F is the resultant force of F2 and F1. Therefore, F is F1 plus F2. For the moment at O, for this, it can define by distance of R to the force F1, which is R times by F1 plus R times by F2. And we can simplify, then we will get MO is R times F. So this explains about Varric theorems. Take this for an example for the principle of moment. For the guide cable, as you can see here, this is the guide cable. Exert a force of F on the pole. Therefore, it creates moment at the base of A. So to find moment about A is F times D, where D is the perpendicular distance between F to A. Also, we can replace this F, or we can resolve into Fx and Fy. For that force, Fy creates a zero moment about A. However, for the Fx, the moment about A is Fx times h, where D is the height or perpendicular distance between point A to force Fx. Then, we apply the same principle of transmissibility. We slide our F to point C. So for the Fx, create zero moment about A. However, for Fy, we will have moment about A where MA is Fy times by B. So B here is the perpendicular distance between Fy to point A. Now let's move to the first example for principle of moment. As you can see here, this bracket subjected to 200 Newton. Then we need to determine moment of force about point A. First of all, we need to draw this diagram. So for the first method, we can use trigonometry. As you can see here, 45 degree is stated. So by making the parallel line with AD at point B, we're going to get a perpendicular distance from point A to point B, which is D. To find D, CB equal to D, 0.1 meter times by cos 45, so we have 0.070 meter. So don't forget this formula for the trigonometry. Then by taking positive clockwise, we take moment about A equal to force times the perpendicular distance. So from 200 Newton to point A will be anti-clockwise. Therefore, gonna be negative because our initial assumption is positive is clockwise. Then for our F is negative 200 Newton times by our D. And our D is 0.070. Then we will have our moment about A is negative 14.1. So if we're going to write in Cartesian vector, we have to make it anti-clockwise. So when is anti-clockwise, this negative 14.1 will transform to positive 14.1. So when we write as Cartesian vector, the answer is in this form. MA is 14.1 K Newton meter. It's because our X is I, our Y is J, and it will resulted as K. That's why our answer in Cartesian vector is 14.1 K Newton meter. That for the first method. Now we move to the second method. For the second method, first of all, we have to resolve 200 Newton into X and Y components. So resolve our 200 Newton into X, we will have F cos 45 degree, while on Y we have F sin 45 degree. So our initial assumption, we take positive clockwise. Moment about A equal to summation of force times D. So for F cos 45 degree, to get to point A, it will be clockwise. That's why here is positive 200 cos 45. While for F sin 45, to get to point A, for the perpendicular distance to point A is anti-clockwise, so negative. That's why here negative 200 sin 45 degree. And for the perpendicular distance, for F cos 45 is 0.1. And for F sin 45, the perpendicular distance to point A is 0.1 plus 0.1, so times by 0.2. Calculate that, so we will get negative 14.1 Newton meter. When we're going to write in Cartesian vector, we have to take anti-clockwise as answer, so we will get 14.1 Newton meter and anti-clockwise. So the answer is MA 14.1 K Newton meter.